Hello folks, my name is Dr. Zachariah Hildenbrand. I'm here with my colleague Dr. Kevin Shug, and we are the Collaborative Laboratories for Environmental Analysis and Remediation at the University of Texas at Arlington. We're coming to you from the Responsible Shale Energy Extraction Conference, which is a very unique event bringing together scientists, concerned citizens, operators, regulators, and technology companies to have an honest series of conversations about environmental stewardship in shale energy.
We'd really like to thank the support of the Cynthia and George Mitchell Foundation and Earth Day Texas for allowing us to put on this event. We believe that this content that we're going to be providing to those who haven't been able to attend is going to help answer and educate a lot of questions surrounding responsible shale energy extraction. So we hope you enjoy the content.
So, without further ado, it's a tremendous pleasure and honor to introduce Dr. and Katharine Hayhoe of Texas Tech University. Again, Dr. Hayhoe is someone that we could be up here talking for hours about her accolades and what she's done. She's published over 100 scientific publications in some of the best journals on the planet. She's advised the Obama administration on climate change. She has been listed as one of Time magazine's top 100 most influential people, Forbes magazine, top 50 most powerful. Really quite an exquisite scientist, but probably the highest praise that I can give Dr. Hayhoe actually stems from a conversation we had last night. And on a personal note, we were talking about science, women in STEM, and I said, it's so hard for people to get grant funding and to find faculty positions. I don't know if I'd want my little Valentina to become a scientist. I want her to have more opportunities than that. Then I watched Dr. Hayhoe last night in action. Eloquent, articulate, able to relate to people's concerns and issues, and it was truly inspiring. And so what I can say is that if my little Valentina wanted to grow up to be like Dr. Hayhoe, I couldn't be prouder. So without further ado, Dr. Katharine Hayhoe.
Thank you so much. That is really the best compliment ever. I'm here today to talk about the future of energy. And I want to start with a little perspective. This is global population. Global population was growing slowly and steadily until when? Until we figured out how to dig primarily massive amounts of coal out of the ground and burn it to power industry, transportation, electricity, and a million other advances of modern life. The reason why we're sitting here today is because of the role of energy in our society. And the reason why we have 7.5 billion people on the planet is for the same reason. When we look at the planet, we often picture our world kind of like this picture from NASA, this pristine, untouched globe. But today, I think a more accurate way to look at our world is not by taking a picture of it at night, but rather by taking a picture of it, not during the day, but at night. If you take a picture of the world at night, this is literally a photograph, you can see lights of the 7.5 billion people around the world, and that is a direct result of the energy industry. Now, the majority of our development, beginning in the Industrial Revolution back in the 1700s, was powered by coal. People were using coal quite a while before that. Did you know when the first air quality legislation came into place? It was in the United Kingdom, in the city of London, in the 1200s. People were burning coal for heat, creating such a terrible fog and pollution, London was famous for its smogs, that the king, Edward at the time, made it illegal to burn coal within London city limits. The penalty was death. We've come a little way since then. We've funded most of our development off coal, but the problem with coal is that it is very dirty. It is very inefficient, and it produces a lot of pollution. Now, to be fair, a lot of this pollution also comes from burning oil and gas. But air pollution is a very serious issue. And if we look around the world, currently there's over 5.5 million deaths per year from both indoor and outdoor air pollution. And in the United States, there's 200,000 deaths per year. That's a pretty high number. For years and even decades now, studies have conclusively shown that because of the health costs and the lost productivity, coal is simply not economically feasible anymore. And back in 2002, I wrote this paper with my colleague from ExxonMobil. I worked extensively with ExxonMobil through the 90s and early 2000s. We wrote this paper back in 2002, which is kind of a scary number of years ago, 15 years ago, actually crunching the numbers on how switching from coal to gas would benefit us from a climate perspective. And today, we are actually seeing that happen. Today, the US electricity sector is in the middle of the biggest shift that's been seen in at least 50 years. It's pretty much the biggest shift that we have seen since the 1700s. And it is the shift from coal to natural gas. Why is it happening? It's happening for several reasons. Natural gas is more efficient, natural gas is currently cheaper, and natural gas is plentiful and abundant. And so today, when we zoom in on the United States, this is that same picture from NASA, when we zoom in on the United States, if you cast your eyes up here to the Dakotas, you can actually see the lights from thousands of fracking wells that are being flared. So we can see the visual impact of this change on our planet. And we know that these changes are happening. So for example, 138 coal-fired power plants were already retired. A number are announced for retirement, and an analysis that was done 4 years ago now, which is quite a while ago. 4 years ago, they concluded that there were 329 more coal-fired power generators that were no longer economically competitive compared to not state-of-the-art, but just a typical natural gas plant. And as we have seen a shift over the past decade, we have seen, oops, I thought I had an arrow there, but it disappeared. We have seen carbon emissions drop. The green line is carbon emissions from the European Union. The blue line is carbon emissions from the United States. Why? Because natural gas produces more electricity per unit burned compared to coal. You can burn it more efficiently. If you look at the EIA numbers, you can see that specifically in the electricity sector, carbon emissions have dropped. And this has led to, as you can see here, this has led to, especially in most recent years, numbers that have shown how the energy-related emissions due to coal, the yellow, have dropped, and then the energy-related emissions related to petroleum and natural gas have increased a little bit. This is just the last 2 years and future projections. Interestingly, this is a headline just today. It isn't just happening in the United States. Today, perhaps coincidentally, perhaps not, since it's Earth Day, the UK has experienced its first coal-free day since the Industrial Revolution. And I would actually venture to say its first coal-free day since the 1200s. Because that edict from King Edward did not actually stop people from burning coal. So if we look at the changes that have happened, this is just showing changes over 4 years. The question is, first of all, why? Why has this happened? When we look at headlines, we often see headlines like this. CO2 emissions dropped due to natural gas, and it went on to say not due to climate policy. And it's completely true, it was not due to climate policy. But as you know, things are always a little more nuanced. And when we start to look at the nuances, we see an interesting story. This is a scientific study that was conducted and published 2 years ago. And they said, the decline has been widely attributed to a shift from the use of coal to natural gas. However, here we're going to analyze the factors, and no surprise, it turns out it's a little bit more complicated. In fact, if you break down the changes that we've seen, and this is an interesting analysis by the Rhodium Group, if you break down the changes that we've seen and we attribute them, just over half, about 60%, were due to changes in economic growth, a downturn in economic growth, and then just under half, about 40 or 45%, was due to changes in the carbon intensity. So the decrease in carbon emissions we've seen have been partly due to economic factors and partly due to the fact that we are changing our fuel mix. So if you take that green bar and you break it out, you say how much of that was natural gas, it turns out that the majority was natural gas. So switching from coal to natural gas was responsible for the majority of that green bar, but wind and biofuels were not far behind. Now I know that natural gas is used for many more things than electricity generation. And it is much more difficult to replace natural gas with other sources in, for example, your furnace than it is in a big power plant system. But at the same time, it is one of the biggest users and it is one of the ones where change is happening the fastest. So what has been primarily responsible for this change? Number one, the economic downturn. Number two, natural gas. And number 3 and 4, increasing use of renewables. So now we get to our second question. Our second question is, what does the future hold? And that's where things get interesting. Now, before we talk about what the future holds, I have to take a small digression. And that digression is into my own field of climate science. Why? Because that relates to my answer to this question. What I'm going to posit to you is that natural gas has often been referred to as a bridge. In fact, in my own field, there's this phrase that I'm so sick of called the climate, water, food nexus. And I'm sure in your field, the bridge analogy is just as common and just as overused, in my opinion. But at the same time, it gives us this good picture of how natural gas can help in this transition between the old ways of getting energy and the new ways of getting energy. But what I want to point out is bridges have ends. If they don't have ends, they look like this. This is literally a picture of an infinite bridge, and if we are on an infinite bridge, we go around in a circle again and again and again. That is not our purpose. Our purpose is to move forward. Bridges have ends, and we are nearing the end of the natural gas bridge, and here is why. 3 reasons why we're nearing the end of the bridge. Before I get into these 3 reasons, though, we need to talk again about the Industrial Revolution. The Industrial Revolution, as I said, was powered mostly by coal, but increasingly by oil and natural gas. And we care about this because burning these things produces carbon dioxide. It is disrupting the natural carbon cycle, taking carbon that would otherwise remain buried under the surface of the earth for millions of years and putting it into the atmosphere over timescales of years to decades. Why do we care about carbon dioxide? We care about it because it is a heat-trapping gas. Our planet, there we go, our planet has a natural blanket of heat-trapping gases. They are naturally occurring. The sun's energy shines down on the earth heats up and gives off heat energy or infrared, and that naturally occurring blanket of heat-trapping gases traps the Earth's heat, keeping us almost 60 degrees warmer than we would be otherwise, Fahrenheit, over 30 degrees Celsius. We would be a frozen ball of ice if it were not for this natural blanket. Then you might say, well, what's the problem then? The problem is that by digging up massive amounts of coal, and then increasingly gas and oil, and burning it, we are releasing more of these heat-trapping gases into the atmosphere, wrapping an extra blanket around our planet that it did not need. Like when I used to stay at my grandma's house and she would sneak in the middle of the night and put an extra blanket on me and I would wake up sweating. In the same way, we're wrapping an extra blanket around our planet that it did not need, and the Earth's temperature is increasing as a result. You may say, well, this is new science. This is unproven science. The science is not settled. I know that scientists are still arguing because every time I turn on the television, there's 2 talking heads yelling at each other. The reality is that we have known that our planet had this natural blanket since the 1830s. We have known that burning coal and gas and oil produced carbon dioxide, which is a key component of this natural blanket, since the 1860s. We have known how much the world would warm if we doubled or tripled this blanket around our planet, and we are well on the way to doubling it by the 2040s today. We have known how much the world would warm since the 1890s. The science that we use to understand what's happening to the planet is the same nonlinear fluid dynamics that we use to design airplanes, the same radiative transfer physics that we use in our stoves and refrigerators. So if we reject the science of climate change, we are rejecting a lot of science that we use every day with no concerns.
Could you say that again, please?
No, it's being recorded. Sorry. And so as a result, the temperature of the planet is increasing. Now, from year to year, it goes up and down, and even you have a couple of years in a row where it doesn't look like it's going anywhere. And so you have congressional hearings and you have headlines saying global warming has stopped, but the reality is climate is the change over at least 20 to 30 years. We can have ups and downs, that's weather, but long term the planet is warming. 2015 was the warmest year on record. 2016 was the next warmest year on record. 2017 probably won't be the warmest year on record. I think we'll go down a bit for a year or two. But long term, the planet is warming. Why do we care about this? First of all, we care because we see the signs all around us, whether it is retreating glaciers, whether it is rising sea level, whether it's the fact that invasive species like kudzu have moved so far north they're already over the border into Canada because the winters are getting warmer that fast. Cherry trees blossoming much sooner in the year, and increasing risk of other extremes like heat waves. If we look around the planet, there are 26,500 indicators of a warming planet, some of those in our own backyards here in Texas. But you might say, still, why do we really care about this issue? Because if you design a book, if you write a book or you create a movie about climate change or, God forbid, global warming, and you ask an artist to design the cover of that book, there's one image they're going to put on the cover of that book, and it is this. And I'm going to be honest, if the only reason we care about a warmer planet is a polar bear, it is going to be much more affordable to build the most amazing habitat. You can take over half of northern Manitoba and no one would probably even notice. I'm Canadian, so I can say that. You can build the most amazing habitat to preserve that species, and we can all go on our way. The reality, though, is that we care about a changing climate because after the polar bear, we are one of the most vulnerable species on the planet. And you might say, how can that be? We're smart. We can see this thing coming. It gets back to that very first figure I showed you. Do you remember what the first figure was of? I know it's early in the morning. Population, yes. 7.5 billion people on the planet. We have built massive cities, and two-thirds of the world's biggest cities are within a few feet of sea level. And sea level is rising. It will rise at least a few feet this century due to thermal expansion, as well as the melting of land-based ice. Why else do we care about climate? Because it determines where we grow our crops. And today the growing zones are changing. They're shifting so fast that in many places the types of crops you grew there are no longer the types of crops you grow today. Farmers in the Midwest are not planting what their grandfathers planted on the same farm. But there is a limit to this, and especially here in Texas, we see that limit. And when your farm can no longer grow what you've always grown, you can't just pick up and move to Kansas because every acre of arable land has already been allocated and purchased. If you have the money, you can, but you can't just go up there and take over somebody's land. And we also, as you can see from this cartoon from California, we also don't even have enough water to go around often. Some places have too much, but in our part of the world, we have not quite enough. And the warmer it gets, the faster our evaporation rates speed up. So when we have a drought, as we always do naturally, in a warmer world, that drought is stronger and lasts longer because of the vicious cycle between heat, evaporation, and drought. We care about a changing climate, not because of the polar bears, but because they exacerbate the risks that we humans, our agriculture, our economy, our water, and even our energy industry are facing today. That's why we care. And when we look to the future, we have a choice to make. because our carbon emissions will determine our future pathway and will determine whether the amount of change can be coped with and dealt with, or whether that amount of change becomes serious and dangerous. If you look at where carbon emissions have come from over the past 100 years and you add them all up, this is what the map looks like. The United States is responsible for over a third. Today, on a year-to-year basis, the United States produces less than China, but over the last 100 years, the United States is still ahead. And then you contrast this map, fix this map in your head, you contrast this map with a map of which countries are most vulnerable to sea level rise, stronger hurricanes and coastal storms, increasing frequency of heat waves, changing patterns of rain and drought. And this is what that looks like. And so this is why the military refers to climate change as a threat multiplier. Because many of these countries are already in unstable political situations. And all it takes is one little push to put them over the edge. And the military believes, and I agree, based on the data, that climate change poses exactly that type of risk. In 1992, 25 years ago, just about every country in the world went to Rio and agreed to stabilize levels of heat-trapping gases in the atmosphere at a level that would prevent dangerous human interference with the climate system. As I mentioned last night, we are currently conducting an unprecedented experiment with our planet. The amount of carbon that we are putting into our atmosphere every year by digging it up from underground and burning it, that amount of carbon at that rate has never been put into the atmosphere as far back as our paleoclimate records go. The time of biggest change and massive disruption, coupled with widespread extinctions, humans were not there at that time. At that time, the rate of carbon emission into the atmosphere, a natural rate, was 1/10 the rate that we're seeing today, 1/10. So that's why one of the things that concerns scientists the most is the potential for surprise. Because we are conducting an experiment that has never been done before, and we are not sure that we know all of the outcomes. But one thing we are sure of, and that is that the vast majority of those outcomes will be negative for humans. Why? Because the perfect temperature for us is the temperature of the planet in which our population went from hundreds of millions to billions. That is the conditions we had over the past few centuries. That is the perfect conditions for our society on this planet. So back to our 3 reasons now. 3 reasons why we are nearing the end of our bridge. Reason number 1. Extracting and burning natural gas does still produce heat-trapping gases. In terms of air pollution, it's much cleaner than coal. In terms of efficiency, it burns much cleaner than coal and produces more electricity and energy. But it still produces carbon dioxide and methane. And we see this in headlines, like this one from Scientific American. Natural gas emissions are surpassing those from coal. And if you actually look at the data, this is the data here. This is looking at energy-related carbon emissions from natural gas. Here's the consumption. You can see coal is dropping and natural gas is going up. And over here on the right-hand side, you can see that the actual emissions did pass coal in 2015, so 2 years ago. Oops. But it isn't only, there we go, it isn't only about carbon dioxide. Natural gas is primarily methane. And if natural gas leaks before we burn it, we're leaking methane into the atmosphere. Satellite observations from NASA several years ago showed widespread methane emissions across the entire United States, many of them concentrated in urban areas because of very old and leaky infrastructure. And they also showed a massive hot spot in the Four Corners area. Further study went on to determine, oops, there we go. I'm missing a slide there, I'm sorry. Further study went on to determine that those come from just 250 very specific sources. And why do we care about methane? We care about methane because one molecule of methane absorbs 35 times the heat of carbon dioxide. In other words, you have to have 35 molecules of carbon dioxide to equal one molecule of methane. It is a very potent heat-trapping gas. And so this article from the Financial Times, I love this because they even use that color background for their website. Isn't that peculiar? And I also love it because right beside it, it talks about the March for Science, which is occurring this morning. The Financial Times had an article about the idea of stranded assets. And stranded assets are a real concept. Insurance companies are often on the front end of planning for the future because they crunch all the numbers and they see the trends before many other people do. And insurance companies, especially the big reinsurance companies, are beginning to divest themselves from fossil fuel holdings because they don't want to be stuck with them as the world changes. So reason number one why we're reaching the end of the bridge is because the world is recognizing we cannot continue to produce heat-trapping gases unabated without serious consequences. Financial, economic consequences. Reason number two, traditional thermoelectric generation, which includes traditional nuclear as well, is vulnerable to heat and drought. This is from the Department of Energy showing the number of power plants that have shut down or reduced their output because of water problems. And interestingly here, the biggest ones that have had these problems are what? Nuclear, followed by coal. So in this way, natural gas does offer an advantage, but anything that needs water is going to be at risk in the future because extreme heat is increasing, evaporation rates are increasing. And if you need water to be a certain temperature, we're going to run into issues. This is the average number of days per year over 100 degrees historically. So historically, this is our average. And then we had the summer of 2011. Anybody, were you here the summer of 2011? Yes. I remember my air conditioning bill vividly the summer of 2011. This is the summer of 2011, and it completely shocked me as a scientist. It shocked me as a human when I opened my bill. It shocked me as a scientist because 2 years before this, I had created another map. I made this map, but I also made a map showing what the average summer would look like in terms of days per year over 100 degrees by the 2040s. And this is the map that I had created. Fix this map in your head, and then compare it to this map. It's almost identical. Imagine power generation in a world where almost every average summer looks like 2011. And furthermore, this is a map showing existing thermoelectric plants. All of those dots are existing thermoelectric plants. And then the colors show areas that are at risk for water supply. And as you can see, especially here in Texas and up into Oklahoma, a great deal of our region is at high risk. What's our third reason? This is a third reason that some of us might not think about that much. And that's the fact that around the world, there are 1 billion people living in energy poverty today. What has enabled us to live this nice lifestyle where we have lights on, we have food to eat, we have clean water, we have comfortable vehicles? Energy has enabled us to get to the point that we're at today. Access to energy is one of the main differences between developed and developing countries, and changing people's access to energy is one of the main ways that emerging economies are transitioning from one to the other. So you might say at this point, isn't the most sensible thing to supply developing countries with the same type of energy that we used? There's a problem with that, though. The problem is they don't have it. Yes, Venezuela has it, and yes, Nigeria has it. But if you look at the entire continent of Africa, they have less than 6% of the world's resources, especially if you leave Nigeria out of the picture. They cannot afford to develop on fuels that they don't have domestically or regionally, because it puts them in debt for a resource. But they do have a lot of other types of resources, like sun and like wind. The world is changing. Developing countries are developing. And today, they're not doing it the way we did it. China is shutting down their coal plants. They're shutting down half-built coal plants. They're shutting down coal plants that are still being planned out. They are replacing them with natural gas, with hydroelectric, but increasingly with wind and sun. They're investing $360 billion in clean energy over the next 3 years to create 13 million jobs. Around the world, we see the biggest solar farm in the world going into Morocco, which was soon surpassed by other big ones. But we're seeing solar farms being built that actually have built-in storage now. I mentioned how the UK is already having its first coal-free day today. And in China, the landscape is also changing. It's changing here in Texas as well. Fort Hood signed a new electricity contract for wind and solar because it was cheaper than natural gas in Texas. Georgetown is going renewable as well to save money. So what does the future look like in terms of our energy? It looks like offshore and onshore wind. It looks like large-scale solar with built-in storage. And it also looks like natural gas being used for peaking because there is no other source of energy that you can turn on and off as fast as natural gas. But it does not look like an infinite bridge in which we walk around and around and around in circles. We are going somewhere. It's only a question of how fast. And because we know the direction in which we're moving, that's why it just makes sense to say, what is the future of energy? The future of energy is a shifting mix that continues to have natural gas in it, but is moving in a different direction, and it makes sense for all of us to prepare for that future. So that when we step off the bridge, there won't be a surprise, we'll know where we're going, and we'll be ready for it. What does the future of energy look like? This is what it looks like in Texas. That's what it looks like in Africa. And the one thing we know is that we all need it. Thank you.
Fantastic presentation, Katharine. Thank you very much. We got some time for a couple of questions here. Many people discard the climate change argument because they claim discrepancies in the data. I hear that a lot, apparently, and a lot from accountants, accordingly.
Accountants.
And disagreeing with scientists. What is the actual ratio of climate believers versus deniers of science, of climate science?
Sure. Wow, that's a great question. So first of all, I want to point you to a great resource called skepticalscience.com. I know there are a lot of questions about the science of climate change, and Skeptical Science I love because they go through each question methodically. They give a short answer, they give a long answer, and then they give you links to the original scientific publications. So you can check them for yourself. Now, you asked a very interesting question, sorry. How many scientists are climate change believers? My answer is none. I don't believe in climate change. I'm a scientist, so I look at the evidence. And when we add up the evidence of over 26,500 indicators saying climate is changing, and when we add up over 150 years of scientific research saying could it be the sun or natural cycles, we find that it would be cooling today if it were a natural cycle. It would be cooling today if it were the sun. There is no other explanation for our warming, and that is why over 97% of scientists agree, they don't believe, they agree, that climate is changing, that humans are responsible, and that humans are the primary cause of that change. The few scientists who are not on that list say climate is changing, and they say, yes, humans have something to do with it, but they argue either A, it isn't that much, or B, it's not that bad. So why is there such a big debate? Whenever we turn on the television, like I said, we see two heads arguing with each other. We don't see 97 or 98 people saying, yeah, it's real, it's us, and we're the biggest cause, and then 2 or 3 people saying, it's real, it's us, but we're not the biggest cause, because that's not really very interesting television. The reality is that we do agree about this. And, as I say, A thermometer is not Democrat or Republican. It doesn't give you a different answer depending on how you vote. The reality is that this is a real issue, but we need solutions to it. We need those solutions to come from the whole political spectrum. And that's why I am so excited by the fact that there are libertarian solutions to climate change. There are free market solutions to climate change. There are bipartisan solutions to climate change. And yes, there are liberal solutions to climate change as well. But we need that discussion to be happening, because by saying it isn't real, half of the political spectrum is cutting themselves out of the solution conversation. And we're going to end up with a very different package of solutions if only half the people in the country are talking about them. Thank you.
Thank you. This is an excellent, really interesting question. From your perspective, should we value research steered towards handling climate change, i.e. developing drought-resistant crops, et cetera, or should we be spending more of our efforts and resources towards finding ways to slow climate change?
That's a great question. So, should we focus more on mitigation, which is reducing our carbon emissions, or on adaptation and resilience, which is preparing for a changing climate? 30 years ago, we had a choice. But 30 years ago, we essentially made that choice. Carbon emissions have continued to grow. The growth rate has averaged 3 to 4% over the past 15 to 20 years. That means that emissions have been accelerating. They're just starting, the growth rate is just starting to drop thanks to innovations that are happening mostly in China and India and emerging countries. But we've reached the point now where we have to do both. We have to figure out how to reduce our heat-trapping gas emissions, how to reduce this extra blanket we're wrapping around the planet, but we have to prepare for a changing climate, because even if we turned everything off today, which we can't and we shouldn't, even if we could do that, we would still be facing impacts tomorrow. And over the next few decades, and even the rest of the century. It's as if we've been smoking a pack of cigarettes a day for 30 years, and we go cold turkey, we're still going to feel the impacts. So the answer, unfortunately, is both. But the problem is we just don't have enough resources to go around.
Yep. You touched on this a little bit, and this will be our last question, unfortunately, because we have to get up into our program. And we're going to try to address a lot of these other questions through our website. You touched on this, but can you comment a little bit on the scale and overall impact of this wasted methane and the burning or flaring in some of these unconventional natural gas extraction sites? How can we be doing this more intelligently?
And that really is the question of the symposium. So back when I wrote that paper in 2002 that I showed you, we used methane leakage rates that NASA study has showed were far too low. If you look at methane loss, we see that it is actually changing the benefits of natural gas compared to coal significantly, in terms of their heat-trapping gas emissions, not in terms of air pollution. But the good news is that NASA found that the majority of those emissions, for example, in the Four Corners area, are coming from a small number of discrete sources. And so getting the low-hanging fruit off the tree first is the way to go. Science has identified which sources those are. You can go around with sensors and actually determine where it's coming from. And the good thing is if you fix these leaks, you're actually saving gas that would otherwise be lost. And the best thing to do with natural gas, once we've got it out of the ground, the best thing to do with it is to burn it, because if we don't burn it, it gets released as methane, which is 35 times stronger.
Well, thank you very much. Fantastic presentation. Let's give her one round of applause.
Thank you.